Hello, Mrs. Hassler here. So we went through the 5.1 lesson, or at least the activity part that we had done in our groups in class. And so I want to give you some more defined notes on this 5.1, give you some vocabulary, some examples, how to interpret this function notation that we're talking about, so that you can use this to help you with your homework and to check your understanding. Okay, so the first thing we're going to talk about is the vocabulary. And so the vocabulary that we have is on functions. And sorry about that. And so we're going to say a function is a rule that takes an output. Sorry, a function is a rule. So we'll say functions are rules that take an input and make it an output. And so the thing that we talked about in our lesson today was something called function notation. I'm actually going to write that up at the top here. What function notation does is it lets us mathematicians, and we are all mathematicians, it lets us mathematicians be very efficient in knowing what information I want. And so what we talked about in class today is that we use this notation, this, excuse me, this f of parentheses equals blank. So what goes inside the parentheses is the input or the x value, and the answer to this notation is the output or the y value. And so if I were to interpret what this says, this would be read as, and I'll put quotes, f of x. Again, whatever's in the parentheses is the input, and the answer to that notation is the output. Now, because we work with multiple functions at a time from here on, this f represents the name. Of that function. Sorry, my pen is like not writing well. So oftentimes we'll use f for the name of the function because f stands for a function. But you'll see as we get into some examples that we like to use things like h or g or k. Or you can see down here in this example, we're going to use n. N is just the name of that function. All right, so let's go down and do this interpret. It says let n of t, right? So I'll write that here, n of t. That's how you read that. Let n of t represent the number of people in line at a barbecue food truck, t hours after the food truck opens. So again, I have this notation, n of t, and we said that the stuff that's in the parentheses is the input. So this t right here, this t hours, that's actually going to represent our input. And so the number of people in line is going to be our output. And if you can read a scenario and understand from the scenario what the input and what the output is, then the interpreting should be manageable. Again, this 1 represents the input, and the 11 represents the output. In this notation, t is the input, so t is the number of hours. So we can say after 1 hour, then the output is the number of people in line. There are 11 people in line, is how I would interpret that n of 1 equals 11. So we're going to have to do some interpreting, some understanding of what the notation represents. All right, let's come over and do some examples using graphs, tables, and an equation. So I have this graph here, and this graph is called the f graph. We're going to name it f of x, or the f graph, f for function. And I know I don't have anything written here, so we're going to go ahead and practice writing. We're going to say, I want to find f of negative 2. It's a negative 2. There we go. And again, the number that's in these parentheses, that's our x value. In other words, when x is -2 right here, I need to line that up and figure out what the y value is for that function. So if I find the point on my graph, that's going to line up with -6. So what I'm trying to find is the y value. This means I'm going to find y when x is -2. So a couple other examples. I've got f of 0. And I want to find f of 6. So if you want to pause the video so that you can try it on your own, that'd be great. F of 0 means I'm going to look for when x is 0, that's here. And that's right on the y-axis. And the y that goes with that is -4. So I found when x is 0, y is -4. And f of 6. So here's 6 on the x-axis. I'm going to go up to my graph, and I go over to 2 on the y. So again, when x is 6, y is 2. So that's how that works. The number in the parentheses is the x, and the answer is the y, the output. So let's come down to the table, and notice that in our table, it says h of x. So this function is the h function. It is not the f function. It is different than the f function. So some things that I might ask you are things like find h of -7, or find h of -1. Again, I can use my table to help me. If x is -7, the output, or the y value, is 12. And if x is -1, the output, or the y value, is 0. Sometimes we might have to find the missing value. So if I say h of blank is 8, I want to know what would go in this blank spot. Well, the input then, the blank spot, would be -5. All right, so let's take a look at this last one here. And this last one here, I have something called the g function. And this time, I want us to find g of -1. Now, I don't have a graph to look at. I don't have a table to look at. So I'm going to have to do some good old-fashioned substitution, right? If this is my x value, then I'm going to replace the x in my equation with -1. So I've got 2 times, I'm going to use -1. I'm going to put that in orange just to kind of show you that I'm replacing the x with that value, -1, and then plus 7. Let's see, 2 times -1 is -2, plus 7 is 5. So g of -1 is 5. All right, so I'm going to give you 2 more. And if you would like to pause so that you can try these on your own, that would be great. All right, g of 0, so I've got 2 times 0 plus 7. It's going to be 0 plus 7, which is 7. And g of 3 means I've got 2 times 3 plus 7. 2 times 3 is 6, plus 7 is 13. So g of 3 is 13. All right, so your job is to make sure that you do the check your understanding, see if you understand what's going on in this lesson. Ask me questions if you're unsure. And then your homework is to do the 5.1 practice, and we will go over that together in class. If you have any questions, let me know.